Hi everyone, we're back talking about simplifying expressions raised to a power. So the reason I wanted to cover this is because in the previous videos, we've been talking about exponent rules, adding, multiplying, dividing, subtracting, so on, right? So um, just as a quick recap, right, in this example here, we said like x to the third raised to the second power becomes multiplying. So power to a power, we multiply the exponents and we would get x to the sixth here, right? So in this case, I wanted to cover what happens when we have a coefficient in front of the x. So in this case, 2. So this 2 is important because the squared will be distributed to the x, obviously, but also to the 2. And a lot of students tend to forget that, so it's an important topic. So it becomes 2 squared times x to the first times 2. Right? So we get, I hope you know, 2 squared is 4, and x to the first times 2 just becomes x squared. Okay, now moving down to this example here. We have 3x squared, so this 3 raised to the third power should go both to the 3 and to the 2. So 3 to the third power, x squared to the third power. 3 times 3 times 3, 27, x to the sixth power. So it's pretty simple. It's just an important concept to make sure you're familiar with and you understand. Now we're going to get into an example here. So I actually wrote this out already to kind of hopefully help the organization a little bit. So let's look right here. I'll use my laser pointer. So we have this whole big term all squared, right? So what happens when we have this 2? It has to be distributed to every single term. It has to be distributed to the 3, to the x, to the y, and to the z, and then also to the 2, to the x, to the y, and to the z on the bottom. So this gets distributed to literally every term. So 3 squared, 4x times 2, y to the 7 times 2, z to the 2 times 2, 2 squared, x to the 2 times 2, y to the 1 times 2, z to the 3 times 2. So please pause if you need to catch up and jot this down, or you want to do it on your own. Once you get here, right, we know 3 squared gives us 9, and then we can multiply all these exponents. So we get x to the 8th, y to the 14th, z to the 4th, over 4, x to the 4th, y squared, z to the 6th. Now, once we have that, we're almost there. We actually all we need left is to simplify our exponents. And we should know how to do this from the video where we explained dividing exponents, right? So we subtract here. So we get x to the 8th minus x to the 4th should give us x to the 4th. Y to the 14th minus y squared should give us y to the 12th. And then z to the 4th minus z to the 6th should give us z to the negative 2. Now remember the rule with z to the negative 2, we keep it on the side to make it positive, right? We keep it on the side with the higher exponent, which in this case was 6. So z to the positive 2 will stay on the bottom, as you can see here. The only other thing that's important to mention is the 9 and the 4. So as you can see, I didn't do anything to the 9 and the 4. They just kind of hang out in the front, which is fine. The only time we would have to do something with the 9 and the 4 is if they were 10 and 4 or 10 and 5, right? Some numbers that have a greatest common factor that we can reduce by dividing them. But we do not ever subtract these numbers. Just because we're subtracting the exponents does not mean we can subtract their coefficients, right? These are two numbers divided. So they are 9 and 4, and it's 9 divided by 4, which does not simplify, so we just leave it. But again, like I said, if you had something like 10 over 4, maybe we could simplify it by dividing by 2. But in this case, that's all we can do. So in this video, I hope you learned a little bit about simplifying expressions raised to a power and how we can use the power rule as well as our other exponent rules to simplify based on this distribution and these previous rules we learned. Thanks, guys.